right, on to lines. First of all, if you have a director vector and one point, or the coordinates of one point, you can find both the Cartesian equation and the parametric equation. Let me give you an example. Let's say you have a director vector, v is 3 minus 4, and you have a point, which is point A, 1, 2. If the line passes through this point, we can find, let me start with the parametric equation. So before you do that, what you want to do, you want to say, let M, which is just a random point, we're going to give it the coordinates x, y, belong to this line. We're going to call the line D. So M belongs to D. Now, to find the Cartesian equation, you need to do the determinant of line AM and line V, or director vector V. So determinant, it's x minus 1, so the points for line AM are x minus 1, so x minus 1 and y minus 2. And then the director vector is 3 minus 4 equals 0, so then you just solve it as you would solve any determinant. Minus 4x plus 4 minus 3y plus 6 is equal to 0. So your director vector, your Cartesian equation, that's 10 is equal to 0. That's your Cartesian equation. Now for the parametric equation, you also need to use line AM, but you need to solve it a bit differently. For this one, you need to have the parameter. We're going to call the parameter t. So to set this up, vector AM needs to be equal to vector t. So we're going to solve this by plugging in the coordinates, which are x minus 1 and y minus 2 is equal to t into 3 minus 4. So x minus 1, y minus 2 is equal to 3t minus 4t. So then you multiply. Not multiply, sorry. You take each side alone. So x minus 1 equals 3t. So x equals 3t plus 1. Y minus 2 equals minus 4t. So y equals minus 4t plus 2. And those are your parametric equations. Now, if you have a Cartesian equation, from it you can find a parametric equation. How do you do this? It's pretty simple. Let's say you have a Cartesian equation. I'm going to use this one up here. Let's say you have Cartesian equation minus 4x minus 3y plus 10 equals to 0. How do we get a parametric equation from this? It's simple. You need to claim that either x or y is equal to t. For the purposes of this one, I'm going to claim y equals to t. So then to find what x is, you need to plug y equals t into the equation. So minus 4x minus 3t plus 10 is equal to 0. And minus 4x is equal to 3t minus 10. So then x is equal to minus 3 over 4t, 10 over 4. Plus 10 over 4, sorry. So now your parametric equations are y equals t and x equals minus 3 over 4t plus 5 over 2. Those would be your parametric equations. Now sure, you might be asking, why is this not equal to this? They're both the same, they're just written differently. So here is how you find the parametric equation from Cartesian equation. Now, if you have a parametric equation, you can find the Cartesian equation. to do so, let me give you this parametric equation. X equals 3t plus 7, y equals t minus 4. So to do this, you need to isolate t on each side. So 3t equals x minus 7, t equals 1 over 3x minus 7 over 3. You do the same for this. T equals y plus 4. This one's easy. So now you can claim that t equals to t. So x minus 7 over 3 equals y plus 4. And then you just cross multiply. You get x minus 7 equals 3y plus 12. You bring it over to one side. X minus 3y minus 19 is equal to 0. And there you have a Cartesian equation from the parametric equation. Now, if you have either two Cartesian equations or one Cartesian and one parametric equation, you can find a point of intersection. To find it from two Cartesian equations, it's simple. You just need to solve it using a system of equations. So let me just give you one. 2x minus 3y plus 9 equals to 0. 4x plus y minus 5 equals to 0. So if you're allowed to use calculators in school, you can directly plug it in to the calculator like this. So obviously you need to move them over. So this could be written as 2x minus 3y equals minus 9. 4x plus y equals 5. Then you just plug those coefficients in. 2 minus 3 and minus 9. And then 4, 1, and 5. And you can get the values for each of them. So x is equal to, according to this, 3 over 7. And y equals 23 over 7. You can also solve it normally. Let me show you how to do that. You just need to be able to cancel this out. So I'm going to multiply it. I'm going to multiply this upper one here by minus 2. So I'm going to get minus 4x plus 6y equals 18. 4x plus y equals 5. And then you just add them together. These will be canceled out. So then 7y equals 23. So y equals 23 over 7, which you can see is the same answer that we got up here. And you just plug this into the equation. I'm going to plug it into this one right here. So I'm going to get 4x plus 23 over 7 minus 5 equals 0. I'm going to get x equals, let me just add these together really quick on my calculator, which you can do in person, obviously. I'm just a bit lazy. Minus 5. So 12 over 7 over 4. So x would come out to 3 over 7, which is, as you can see, what we got right here. Now, if you have one Cartesian and one parametric, it's almost easier to do it. Let's take this Cartesian right here, and parametric 3t plus, let's make that 10, and y equals t minus 4. So what you gotta do, you need to replace this x with this x, and this y with this y. So you get 4 into 3t plus 10 plus t minus 4 minus 5 equals 0. And you keep solving this. 12t plus t, 40 minus 9 plus 31 equals 0. So t equals minus 31 over 13, which you then replace this into here and you get the coordinates of the x and the y. So I'm just going to plug them into my calculator because it's faster. Just show you what I'm doing over here. So I'm plugging this t, first of all, into this. So minus 31 over 13 minus 4 is equal to minus 83 over 13. So y equals minus 83 over 13. And x is going to be equal to, let's see, so we've got t right here. 3 times that plus 10, which is going to be equal to 37 over 13. So there you have the intersection point between this and this using a Cartesian and a parametric. Now, you can find parallel, you can find that you can prove that two lines are parallel by using their director vector. So let's say one director vector is 1, 2. For the other one to be parallel, their determinant needs to be equal to 0. Now, for two of these to be perpendicular, the dot product of the two vectors, let's call this one once again, the perpendicular of this, okay, would be equal to 0. So the dot product is equal to 0, that makes them perpendicular. For the determinant to be equal to 0 makes it parallel